Hello class, I've never tried to do this before, but I am going to give a video lecture to finish up our Module 5 that we did not finish in class on Tuesday. Previous years we started Module 5 class at 9:30 instead of at 10, and that's how I managed to get it finished in one class. So since we didn't do that, you can listen to me lecture from your home instead of coming to class half an hour early. So I hope that works for everybody. We are starting out here on page 146 with acids and bases. You will see, hope I can keep this focused, right here, an acid group is formed by one carbon atom with a double bond here to an oxygen on one side and a single bond to an oxygen and a hydrogen right here. These form almost all of the acids that will exist in nature. What do we mean by an acid? Acids are generally things that taste sour, as our book says here, like fruit juices and things like that have acids in them. And the opposite then of an acid is, of course, a base, or something that is alkaline rather than acidic. If we move over here to the next page, focus in, there we go. Figure 5.5, acetic acid, vinegar, looks like this. We also have citric acid, which is found in lemons and any of the citrus fruits. That's where we get the name, where we have actually 3 acid groups linked to the molecule. And down here we have a fatty acid group. This is a term that you might have heard of already if you've heard of omega-3 fatty acids or omega-6 fatty acids. Okay, fatty acids are these long carbon chains with all these hydrogen bonds to them, and at one end we have an acid group, and these form fatty acids, which we will see later link together to form lipids or fats. Okay. Another type of acid that we'll talk about a little bit later are amino acids, and amino acids all link together to form proteins. But for now, let's look at, focus please, figure 5.6. Okay. When we want to measure whether something is acidic or basic, we use the pH scale. pH, we have this lowercase p and this uppercase h, that stands for the power of hydrogen. And on this scale, 7 represents neutral. Something that has a pH of 7 is neither acidic nor basic. If we move down this way, we're getting more and more acidic. We have tomato juice, vinegar, and lemon juice. Or all the way down here at between 0 and 1, we have battery acid. And then if we move the other way, remember we said that acids taste sour. If we move the other way into the bases, these taste bitter. If you've ever tasted baking soda, that falls somewhere in here in the 9-10 range, and it tastes really terrible. We move up here into ammonia, which can be used for cleaning, and lye all the way up at 14, which is used for soap making. Our bodies, our blood, falls just slightly alkaline. 7.35 to 7.45 is where we want that to be. And even though so many of the things we eat, take into our bodies, fall down here in the acidic range, our body still maintains much of its pH up here in the just barely basic range. Okay, so using this, we'll move down here to the on your own questions. I'm going to just hold the camera on the chart and talk through the question. We have 4 different solutions. We have a solution with a pH of 8.1. We have a solution with a pH of 1.1, one with a solution of 5.5, and one, I'm sorry, with a pH of 5.5, and a solution with a pH of 13.2. Okay. Now, our book asks us which of these solutions is the most alkaline. So if we're looking for the one that takes us the farthest to the right on this scale, that would be solution D, 13.2. And the next question is which solution is the most acidic. That will be the one that takes us farthest to this side on the scale, which would be solution B, 1.1.